So here's our little, based on our shape that we just drew, to find the area of a triangle, halve or divide by 2 the base times the height. If we took just the base times the height, we would get the area of a parallelogram, right? But if we take the base times the height and divide it by 2, it'll give us half that area of a parallelogram, which is a triangle. Have. So, bless you. That's just the verb. To have means to take half. We talked about this last time, but it's important, especially when you have a lot of different dimensions. The base and the height must meet at a right angle. Okay, if they don't meet at a right angle, they're not the base and the height. Okay, so here's an example of a little triangle. We've got our base. The height of the triangle, notice, it's not any of the sides in this case. Do you see that? The height of the triangle isn't any of the sides. It actually goes up through the middle because that's where it meets the base at a right angle. So our height always, just like with parallelograms, must meet the base at a right angle. All right, so here's our 2 formulas. You can use either one. That was kind of a lot of writing at once. I'm going to put these in a little box for you. These are our formula for area of a triangle. Area of a triangle is equal to 1/2 base times height, or these both say the same thing, just in different ways. Area of a triangle equals base times height divided by 2. So you can choose which one you like better. I like this one better. Base times height divided by 2. But they are the exact same thing. Where you do the base times height and divide it in half. Okay, so that's how we would find the area of a triangle. Here's example 1. This one's nice because the sides actually meet at a right angle. Right? So it's very easy for us to figure out the base and the height. It doesn't matter which one you call which, but this would be our base, and this would be our height. Please start by writing the formula. Start by writing the formula. Area of a triangle equals base times height divided by 2. This makes it easy for us to plug in what we know and solve. So area equals, our base is 5, times our height, which is 8, divided by 2. Okay, and then we can simplify. We'll do our multiplication on top. 8 times 5 is 40, divided by 2 is 20. So the area of this triangle is 20 inches. And we always put our units squared for area. 20 inches squared, or 20 square inches. Here's a triangle that looks slightly different. Notice that the sides do not meet at a right angle. And here's what they give us. So they give us the height of that triangle. It's not one of the sides. But that's the only place that we have a right angle, is way out here. They give us a little imaginary line that draws down to meet that base at a right angle. So our base is what? What's our base, Liam? 12. Good. And what is our height of this triangle, Roger?
9.
Yeah. Okay. Our base is 12. Our height is 9. Let's find the area of the triangle. Start with our formula. Area equals base times height divided by 2. And then I'm going to plug in what I know. Area, I don't know that yet, equals base, which is 12, times height, which is 9, divided by 2. Okay, then I do my multiplication on the top. 12 times 9 is, Sam?
It's 50. The final answer is 54.
Okay, what's 12 times 9?
108.
Okay.
Divided by 2 is 54.
Thank you. I want to do it step by step. 108 divided by 2. So the area is equal to 54. In this case, it's meters squared. Yep, we always put the units as square units because it represents an area that something takes up. So it's not just a line. Now what they're going to start to do is maybe they'll give you the area and the height, and you have to find the missing piece. So maybe you have to find the length of the base. For example, here's what we're given. The area of this triangle is 56 millimeters squared. The height is 12. We are asked to find the base. We don't know it. We need to find the base. Please start with what? What do I want you to write every time?
A equals A, H equals.
The formula. Start with the formula. Area equals base times height divided by 2. Plug in what we know. Do we know A? Yeah, we do. We do know A. They told us what A equals. So we can plug in 56 equals base, we don't know, times height, which is 12, divided by 2. Okay, we need to go back. I'm going to have you think about this in terms of equations and inverse operations. Look at on the side with the fraction, base times 12 divided by 2. We need to get rid of that divided by 2 on the bottom. To get rid of that, we have an equation here. We should do our inverse operation of division. What's the inverse operation of division? Multiplication. So if we multiply by 2, right, we can get rid of that 2 on the bottom. And if we do it on one side, we have to do it on the other side. So that's why we learned equations before we learned area and solving for area and pieces of area. So 2 times 56 is 12, 112 equals B times 12. My last step is going to be to do what? Divide by?
2B.
No, I want B by itself.
A. 12.
Good.
2. 12. 2.
Okay, you guys, when we talked about equations, we talked about cover up your variable term. This is B times 12. In order to get B by itself, we need to do the inverse operation of multiplication. What's the inverse of multiplication?
Oh, division.
Division. So we need to do what on both sides? Divide by 12. Because then we get B by itself. If we divide one side by 12, divide the other side by 12 so that we get that B all alone. What's 112 divided by 12? Is it going to be? Oh, this is annoying. 9 1/3. Unless I did something wrong. It doesn't go in evenly. It doesn't go in evenly. Well, it would be 0.333333. So I'd rather have you do it as a fraction. Here's what else you could do, you guys. Can you simplify this fraction? This is also acceptable, right? These are both divisible by 2 for sure, right? What about 6? No. 4. Yeah, let's do 4. I think that's the biggest common factor is 4. So 112 divided by 4. Let's do that and get our numerator. 3. Bring down the 2. 4 goes into 32 8 times. Okay, so we divided by 4 on the top, we get 28. Divide by 4 on the bottom, what's 12 divided by 4? 3. Okay, so you could say 28 over 3, or if you changed it into a mixed number, 9 1/3. And we need to label it. This is in millimeters. That one's pretty annoying. I hope that we generally get whole numbers rather than fractions, because that's just kind of annoying to work with. Let's do another one. Find the missing dimension. All right, we are given an area. We are given a base. So we are going to need to solve for which dimension is missing. Liam? The height. So the height would be out here, right, at a right angle. We need to figure out what the height would be. All right, start with what?
A equals B, H divided by 2.
Very good. Area equals base times height divided by 2. Now let's plug in what we know. Do we know the area?
Yes.
Yeah, 175. Do we know the base?
Yes.
Yes, 20. Do we know the height?
No.
No, that's what we're looking for. Divided by 2. This is the trickiest part. I think this is the part that's throwing you guys the most, so pay attention. We want to get rid of that 2 on the bottom, right? We want to get rid of that. When we're working with equations, to get rid of something divided by 2, we should do the inverse operation of divided by 2, which is times 2. And if we multiply by 2 on one side, we
Multiply on the other.
do the same thing. Multiply by 2 on the other side. 175 times 2 is 350. Equals 20 times H. Are you with me there? To get rid of the 2 on the bottom, multiply by 2. It's the opposite of dividing by 2. Inverse operations for equations. Now our last step, we want to get H by itself. 350 is equal to 20 times H. If I cover up this variable term, I'm left with, oops, that's not the variable term. This is the variable term.
Divided by 20.
Correct. We're going to do the inverse of multiplication, which is going to be divide by 20, because we want that H by itself. If we divide one side by 20, we must divide the other side by 20. And this is going to give us a decimal, 17.5 equals H. And what are the units of that 17.5? Feet.
Square.
Just feet, because it's not the area, it's just one side. The area gets squared, but the dimensions, the length and height, are just straight up. Okay? Composite figure. Composite figure is a figure made up of more than one shape. So it might contain, a rectangle and a triangle, or 2 rectangles sort of at different angles, like an L or something like that. So composite will have more than one shape that it's made up of. More than one shape that it's made up of. You're going to be asked to find the area of composite figures. So you'll be given something that maybe has a triangle and a parallelogram, or 2 parallelograms or something like that. And asked to find the area. Yes.
Technically, couldn't any shape be a composite figure, because you can turn anything into another shape?
Could kind of divide it up. Yeah. I think I would sort of agree with that assessment. Yeah. To find the area, if you see a composite figure, separate it into figures that you know. So we know how to find the area of a parallelogram. We know how to find the area of like a rectangle or a triangle now. This is called decomposition. You break it into smaller shapes that you can find the areas of. And then find each of those and add them together. And that gives you the entire area. So decomposition. Okay. Of using decomposition. Look at example 3 here. So this is a golf course, supposedly. That's what they say. It says find the area of the entire fairway. And the fairway is like the striped part. Find the area of the entire fairway between the two streams. Now, we want to separate this into figures we know how to find. It is tempting to see this. Let me put this at a different color. Right, to kind of go along here. But that doesn't give us two figures that we know how to find. Right? Where do you see you could draw a line? What do you think, Dylan?
You can have a triangle, like where the
Yep. Here.
yeah, like
Do you see that? So we've got a triangle. Can we find the area of that triangle? Sure. We also have a rectangle. So we could decompose this whole fairway into two shapes that we can find that area of, right? Okay, let's start by indicating we would know the entire area of this would have to be the area of a rectangle or a parallelogram. How do we find that? What's the area of a rectangle or parallelogram? Kennedy? Base times height. And we're going to add the area of the triangle. How do we find area of a triangle? Sam?
Base times height divided by 2.
Good. Base times height divided by 2. So let's make sure that we know what each of these are. What's the base of our rectangle? Sam?
40 yards.
40 yards. And what's the height of our rectangle, Modibo? 70 yards. Okay, so let's plug those in. Base times height. That's for our rectangle. Then let's look at our triangle, being super careful. What's the base? What's the length of the base of our triangle? 40. We need to find the height. Is the height 50?
30.
Yes or no? Is the height 50? No, because why? Why is 50 not the height? Colin? It does not meet at a right angle. So be careful. You are given this, but we're not going to use it. It's just sort of out there. So don't use it because it doesn't meet the base at a right angle. Instead, Modibo, what would the base be? Or sorry, the base is 40. What would the height be?
40.
No? Roger, what do you think?
70 yards.
No. 70 yards is this whole thing. Right. Listen, watch this. Do you see how that whole long side is 70? Right? What about this long side is 40? What would this then be? 30. 30 is the height of our triangle. Do you see how we got that?
Yeah.
Okay, let's plug in what we know to the area of the triangle. The base we said was 40. 40 down here. And the height we said was 30, and we'll divide that by 2. Now we just find the area of that whole fairway by doing the math. 40 times 70 is 280. 4 times 7, 28. 2,800. Yeah, 2,800. Okay, and then 40 times 30. 4 times 3 is 12, so 1,200. Divided by 2 is 600. So the total area of that fairway, 2,800 plus 600, would be 3,000. No, plus 600.
3,400.
3,400.
3,400.
Oh, that's an A.
Okay, and this would be in what units? Okay, good. yards squared. Okay, the last thing I just want to make sure. Whoops, I didn't mean to do that. Next. Okay, remember, just in case this comes up again today. Okay, if the units are different and you have to convert. Different. Okay, so for example, if you're given, a triangle. Oh gosh, that got real squiggly. Let's try that again. If you're given a triangle, and let's say, and you are asked for the area in feet, right? So if you're given a particular shape, it's in a type of units, and you're asked for different units in your answer, remember that you need to change the dimensions. Yes. First. So before you do your multiplication, first make sure you change this to feet. 12 inches is 1 foot. 24 inches is 2 feet. Then you plug into your formula. Okay? So first change your dimensions on your shape, then do your formula to find the area.